So to start off, the one and only cable that we use for networking is called the Ethernet cable. That being said, there are also several categories of Ethernet cables. They're referred to as CAT for shorthand. There's CAT5, CAT5E, CAT6, CAT6A, CAT7, and more. I'll start off by saying CAT5 is obsolete. Why? Well, it has 100 megabyte transfer speed being the amount of data it can transfer at once. And when you compare that to today's most common cable, the CAT5e cable, which can support up to 1000 megabyte per second transfer speed, you'll see who's the clear winner. Both have 100 meter length limitations, which means that they can run for 100 meters or 328 feet without performance defects. If you create a CAT5e cable that's longer than 100 meters, you're going to start seeing some performance issues. For most of today's networks, CAT5e is really all you need. Most home and small business networks aren't even capable of 1000 megabyte transfer speeds. If you're out doing a cabling job and you want to future-proof the building you're cabling, you might want to opt for CAT6 or CAT6A, which are approved for much higher speeds. They're still the same cable, just improved so that the interferences between the inner wires are kept to a minimum. That's really all there is to these higher category cables. All Ethernet cords, regardless of category, contain the same 8 wires. It's how they're arranged that change up their speed and latency. So, in order to appreciate CAT7, let me quickly go over the previous categories and show you how they've improved. So, the category 5 cable has 8 inner wires, but it has 2 twisted pairs inside. The twisting method is what helps keep out interference. Now we look at the category 5E. It's got the same 8 inner wires with all wires twisted, so we have 4 pairs of twisted wires. This reduces interference and crosstalk even more. The category 6 cable, the same 8 wires, but this time instead of twisted pairs, there's a plastic rod running through the middle of the cable to keep every cable as far apart as possible. And the plastic rod method turned out to be pretty useful because CAT6 cables can now handle up to 10 gigabyte transfer speeds. And then we have the CAT6A cables, which have double the frequency of CAT6. Frequency being the amount of data it can carry at once. So how does CAT6A do this? There's a thicker plastic rod. The wires are carefully and precisely twisted around the plastic rod. And on top of that, the shielding itself has grooves to further separate the space between wires. As a result, they're also much heavier, thicker, and of course more expensive. Now we'll get to the CAT7 cables. This category of cable actually puts a shielding around each of the 8 inner wires inside, which even further limits interference. They're still rated at 10 gigabytes, but they've been shown to handle up to 100 gigabyte speeds in lab environments. They also have more than double the frequency of CAT6A cables. So CAT7 cables are truly useless to the majority of us, but for those out there with server farms and large data centers, they could prove useful. In my opinion, for most of us, there's no need to go past CAT6A, even for future proofing. But as always, if you or your client doesn't care about cost, then go for it. The last type of Ethernet cord I want to mention are plenum cables. Plenum just refers to the shielding, so any category cable can come with plenum shielding. They're strictly used for cable that's run through vents or other areas that are subject to extreme conditions. That's because these plenum cables are designed to not release toxic fumes if they're heated or if they catch fire. They're also much more expensive. So don't plan on getting plenum cables unless you plan on running your cables through anything like heating ducts or piping. In this course, I'll be demonstrating everything using CAT5e cables. Don't worry though, like I mentioned, all cables have the same 8 inner wires inside. So everything I show you will work the same for all categories above CAT5. So now that you have an idea of the different Ethernet categories, let's cut open some cable and see what's inside.